I need to tell you something that happened 6 days ago at Goddard Space Flight Center. Something that has set the astronomical community into what I can only describe as controlled chaos. On January 14th, the Hubble Space Telescope turned its instruments toward an object we have been tracking since last year. An interstellar visitor. The third one humanity has ever observed. And what Hubble saw has forced every expert I have spoken with to reconsider what they thought they understood about objects from beyond our solar system. My name does not matter. What matters is what I am about to share with you. I have covered space science for 43 years. I have reported on missions to Mars, flybys of Jupiter, the discovery of exoplanets. In all that time, I have learned to distinguish between scientific curiosity and scientific alarm. What is happening right now with this object, designated 3I/Atlas, falls into the second category. And I want you to understand why before this week concludes. Because 6 days from now, on January 22nd, we will have an observational opportunity that occurs perhaps once in a civilization's lifetime. And what we learn during those hours may fundamentally alter our understanding of what exists in the cosmos beyond our sun. Let me start with what we know for certain. The Hubble Space Telescope made 6 separate observations on January 14th. The timing was deliberate. 3I Atlas had just passed perihelion, the closest point in its trajectory to our sun. This is when cometary objects, bodies made of ice and rock, typically display their most dramatic activity. Heat from the sun vaporizes frozen material on the surface. Gas escapes. Dust is dragged along with it. This creates the characteristic tail we associate with comets. The process is well understood. We have observed it hundreds of times. What Hubble photographed that day does not match that pattern, not even remotely. The telescope used its Wide-Field Camera 3, the VIAS configuration specifically. High resolution, designed for exactly this type of observation. And what appeared in those images was a halo of material extending more than 130,000 kilometers from the nucleus. Bright, extended, clearly active. But here is where everything I just described breaks down. The dominant feature in that halo, the most prominent structure visible in the data, is pointing in the wrong direction. It is pointing toward the sun, not away from it, toward it. In my 4 decades following this field, I have seen sunward features before. They can appear under very specific viewing geometries. When Earth, the comet, and the sun align in particular ways, perspective can create the illusion of material extending sunward. But these features are faint, transient. They wash out quickly when you process the images. The feature Hubble captured is none of those things. It is broad. It is bright. And when astronomers applied enhancement filters to isolate the fine structure within the coma, what emerged was not an illusion. It was a physical object. A sunward anti-tail. Dominant. Unmistakable. Extending deep into the region where solar radiation pressure should be sweeping everything in the opposite direction. Now let me be very clear about what this means. Solar radiation, the stream of photons emitted by our sun, exerts pressure on particles. This is not theoretical. This is measured, documented, predictable. Dust particles released from a comet near the sun get pushed away from it. Always. The smaller the particle, the stronger the effect. This is why comet tails point away from the sun, regardless of which direction the comet is traveling. The physics does not allow exceptions. And yet, here we have an exception. A tail of material extending sunward against the pressure that should prevent it from existing. But that is not the only anomaly. When scientists processed the Hubble images using what is called a Larsen-Cecchinina rotational gradient filter, a technique designed to remove the smooth glow and highlight asymmetries, 3 additional structures became visible. 3 jets, arranged symmetrically around the nucleus, each separated by approximately 120 degrees. Perfect spacing, perfect geometry, and none of them aligned with the expected anti-solar direction. None of them. Let me stop here and explain why this matters. When a comet develops jets, they form because specific regions on the surface heat up as the object rotates. These are called active regions. A patch of ice gets exposed to sunlight. It sublimates. Gas escapes. A jet forms. But these jets are random, chaotic. They appear and disappear as the surface rotates. They fluctuate in strength. They do not organize themselves into symmetric patterns. Natural processes do not produce geometric perfection. Erosion is uneven. Heating is irregular. Surface composition varies. You do not get three jets spaced exactly 120 degrees apart unless something very specific is controlling their formation. Unless there is structure beneath the surface dictating where and how material escapes. The Hubble observations spanned roughly 30 minutes, 6 separate exposures. During that time, the jet configuration remained stable. It did not flicker, it did not reorganize. It rotated slowly, yes, but as a unit, as a coherent system. And this matches earlier data from December of last year, when Hubble first captured this jet structure. Over weeks, the pattern rotates with the object. Over minutes, it holds steady. This is not random outgassing. This is organized, repeatable, intrinsic to whatever 3I Atlas actually is. Now I need to introduce a complication, a second layer of strangeness that makes the simple explanations impossible. Before perihelion, the SphereX mission detected spectral signatures around 3I Atlas consistent with surface ice. Water ice, carbon dioxide ice, the kind of material you would expect on an interstellar object that has been drifting through the frozen void for billions of years. After perihelion, after the object heated up as it swung past the sun, those signatures changed. The surface ice largely disappeared. In its place, astronomers detected something else: organic molecules, complex carbon-based compounds in the gas phase, and a dramatic increase in water vapor production. Let me walk you through what this implies. For organic molecules to survive billions of years in interstellar space, they must be shielded from cosmic radiation. Cosmic rays destroy organic compounds, break them apart at the molecular level. The only way these molecules persist is if they are buried, protected beneath a substantial layer of other material, several meters thick at minimum. Which means 3I Atlas is not a loose pile of ice and dust. It has depth. It has internal structure. Layers that only became exposed when the outer shell heated and sublimated near the sun. And this brings us to the central problem that is keeping researchers awake at night. How do you create a sunward antitail with material that should be pushed away from the sun? The explanations being discussed all require departures from normal cometary behavior. One possibility is that the antitail consists of large ice fragments, chunks massive enough that their inertia overcomes radiation pressure. They continue moving sunward despite the forces acting against them. But if that is the case, where is the fragmentation coming from? What process is breaking off pieces of ice large enough to resist solar pressure, but small enough to form a visible tail? We have no mechanism for that, not one that fits the observations. The alternative explanation involves dust grains far larger than anything we typically see ejected from comets in our solar system. Grains big enough to have significant mass, big enough that radiation pressure becomes negligible. But again, how? Standard sublimation does not loft large particles. The gas pressure is too weak. You need explosive outbursts. You need subsurface pressure buildups. You need conditions we do not observe in regular comets. And even if you grant those conditions, you still have to explain the symmetric jet system, the stable rotation, the layered composition. I spoke with 3 researchers yesterday. None of them wanted their names used. All of them are directly involved in analyzing the Hubble data. And what struck me was not their uncertainty. Scientists are always uncertain. That is the nature of the work. What struck me was their language, the way they framed the problem. One of them said, and I am quoting directly, "We are running out of ordinary explanations." Another said, "Every model we test requires assumptions we cannot justify." The third simply said, "I do not know what this is." Now let me introduce the subplot that is developing parallel to the scientific investigation. There is a race happening, a global effort to point every available telescope at 3I Atlas before it moves too far from Earth and becomes unobservable. The Gemini Observatory is involved, the Keck telescopes in Hawaii, ground-based facilities across Chile, infrared observatories, radio telescopes, and they are all coordinating, sharing data in real time, building a composite picture of this object from every wavelength, every angle, every possible measurement. This level of mobilization is unusual. It happens for supernovae, for gamma-ray bursts, for events that occur once and never repeat. It does not happen for comets, not typically. But 3I Atlas is not typical. And here is where the timeline becomes critical. On January 22nd, 6 days from now, Earth will pass through a very specific alignment. We will be positioned within less than 1 degree of the direct line between the Sun and 3I Atlas. Imagine looking at a full moon. You are seeing maximum reflected light because the Sun, Moon, and Earth are aligned. The illuminated surface faces you directly. The same geometry applies here. On the 22nd, observers on Earth will be looking almost straight down the sunward anti-tail. We will be staring directly into the structure that should not exist. This alignment allows for measurements that are impossible from any other angle. Brightness, polarization, spectral composition. When light scatters off particles, it picks up signatures that reveal the size, shape, and material properties of those particles. Large, icy fragments scatter light differently than fine dust grains. They polarize light in characteristic ways. The geometry of the 22nd gives us clean data, no angular complications, no ambiguity introduced by perspective. If the anti-tail is made of large ice chunks, we will know. If it is outsized dust grains, we will know. If it is something else entirely, something we have not considered, we will see that too. But there is a tension here, a disagreement forming within the research community. And I want to lay this out clearly because it represents two fundamentally different ways of interpreting the same data. On one side, you have scientists arguing for natural explanations. They point to the organic molecules as evidence of a deeply frozen interstellar comet that is now outgassing as it heats. They explain the jets as active regions tied to rotation. They suggest the sunward anti-tail might involve unusual particle sizes, but insist the underlying physics remains conventional. Heat, sublimation, outflow, just with parameters we have not observed before. This camp says 3I Atlas is strange, yes, but explicable. Give us time, give us more data. We will fit it into existing frameworks. On the other side, you have a smaller group asking whether existing frameworks are adequate. They point to Oumuamua, the first interstellar object detected in 2017. It showed no cometary activity despite passing close to the Sun. No tail, no coma, just a tumbling rock that accelerated in ways inconsistent with gravity alone. Then came 2I Borisov in 2019. It behaved like a textbook comet, entirely normal. Now we have 3I Atlas. Cometary activity, yes, but organized in a way that defies standard models. 3 objects, 3 entirely different behaviors. This group is asking whether we should expect interstellar objects to fit categories derived from solar system observations, whether the diversity we are seeing reflects formation conditions in other stellar systems that differ radically from our own. Let me give you a concrete example of what this means. In our solar system, comets form in 2 main regions: the Kuiper belt beyond Neptune, the Oort cloud far beyond that. Both regions have similar compositions because they formed from the same protoplanetary disk. Same raw materials, same processes. Comets from these regions behave predictably, but 3I Atlas did not form in our solar system. It formed around another star, in a protoplanetary disk with potentially different chemistry, different temperatures, different radiation environments. The ice could be different, the dust could be different, the internal structure could be different. And if that is true, then trying to understand 3I Atlas using only solar system comet models is like trying to understand a whale using only knowledge of goldfish. You are studying the wrong reference class. This is not fringe speculation. This is the conversation happening in institutional meetings right now. NASA's Jet Propulsion Laboratory has convened multiple sessions since the Hubble data arrived. ESA's Space Science Coordination Center is doing the same. These are not enthusiastic amateurs. These are senior scientists with decades of experience looking at an object that does not behave according to the rules they have spent their careers refining. And what troubles them is not that 3I Atlas is strange. Strange is expected. What troubles them is that it is strange in very specific ways, ways that suggest design, organization, intent. I want to be very careful with that word, intent. I am not suggesting anything beyond natural processes, but natural processes produce randomness, chaos. When you see symmetry, when you see stable geometry, you are looking at constraints, at underlying order. The three jets, spaced 120 degrees apart, imply something beneath the surface controlling where gas escapes. Could be subsurface cavities, could be compositional variations in the ice, could be structural features formed during the object's creation billions of years ago. All of those are natural, but all of them require 3I Atlas to have properties we have never observed in a comet, to be built at a fundamental level differently. And this is where the January 22nd observations become essential. Because if the anti-tail is made of large ice fragments, that tells us something broke apart, something fractured. If it is large dust grains, that tells us the sublimation process is far more violent than expected. If it is something else, if the polarization data comes back showing particle properties that do not match ice or dust, then we are in uncharted territory. Truly uncharted. And the scientific community will have to confront the possibility that interstellar objects represent a category of phenomena we are not yet equipped to interpret. Now let me bring you up to date on the latest development. This broke 11 hours ago. A team using the Atacama Large Millimeter Array, ALMA, detected a change in the radio emissions from 3I Atlas. The signal intensity increased, not gradually, abruptly, over a span of less than 2 hours, and the frequency distribution shifted. The spectrum now shows enhanced emission in bands associated with complex organic molecules, specifically formaldehyde and methanol. These are molecules we expect from comets, yes, but not in these concentrations, not increasing this rapidly, and not while the object is moving away from the sun. Cometary activity typically peaks at perihelion and then declines. 3I Atlas passed perihelion weeks ago. It should be quieting down. It is doing the opposite. I want to emphasize what this means for the timeline. We have 6 days until the critical alignment. 6 days to prepare instruments, coordinate observations, allocate telescope time. And now we have an object whose behavior is escalating, whose activity is intensifying at the exact moment when Earth is about to align with the most anomalous feature in its structure. That is either extraordinary coincidence or we are missing something fundamental about how this object operates. The observatories are ready. The instruments are calibrated. The data collection protocols are finalized. On the morning of January 22nd, dozens of telescopes across the planet will turn toward the same point in the sky. They will measure brightness to unprecedented precision. They will analyze polarization signatures. They will capture spectra across wavelengths from radio to ultraviolet. And by the evening of that day, we will have answers. Not all answers, but critical ones. We will know what the anti-tail is made of. We will know whether 3I Atlas is releasing material we can explain or material we cannot. We will know whether the symmetric jet system is an artifact of internal structure or something else entirely. But here is what keeps me coming back to this story. Here is what makes me believe this object is more than just another unusual comet. It is the pattern. Oumuamua gave us a tumbling rock with unexplained acceleration. Borisov gave us a normal comet, a control case. 3i Atlas gives us organized strangeness, symmetry, stability, structure. If you are designing a sequence to gradually introduce humanity to the idea that interstellar space contains objects fundamentally unlike anything in our solar system, this would be a reasonable progression. Start with something inert but anomalous. Follow with something familiar. Then present something active but organized. 3 data points, 3 different lessons. I am not suggesting design. I am observing pattern. And patterns demand explanation. Right now, the explanation being offered is that each interstellar object reflects different formation conditions in different stellar systems. That is plausible. That is reasonable. But it also means we are only beginning to sample the diversity of what exists out there. If 3 objects can be this different, what will the 4th show us? The 10th? The 100th? Are we prepared for the possibility that small bodies in the galaxy span a range of structures and behaviors far wider than anything represented in our own solar system? These are not rhetorical questions. These are operational questions. Questions that affect how we design detection systems, how we allocate observation time, how we interpret future data. And the answers begin on January 22nd, 6 days from now, when Earth aligns, when the instruments focus, when we look directly into the structure that is rewriting our assumptions about what interstellar visitors can be. I will be watching those observations. I will be following the data releases, and I will report what we learn. Because this is not just about one object. This is about opening a window into formation processes occurring around other stars, into environments we cannot visit, into physics operating under conditions we can only infer. 3i. Atlas is the 3rd interstellar visitor humanity has detected. It will not be the last. And everyone teaches us something about the galaxy beyond our small corner of it. Subscribe to this channel if you want to follow this story as it develops. The January 22nd data will start appearing within hours of collection. Analysis will follow within days, and I will walk you through what it means, what it reveals, what it forces us to reconsider. Because 6 days from now, we point our best instruments at an object from another star system, and we ask it what it is made of, what it can teach us, and whether the rules we think govern small bodies in space are truly universal or merely local. The clock is running, the alignment is coming, and I will see you on the other side of those observations, with whatever answers we manage to extract from an object that, so far, has given us nothing but questions.